Okay. Okay. So, in our last class, you and I basically went over the basics of electrochemistry, right? We
Yeah.
talked about your cathode, we talked about the anode, we talked about electrolysis of molten compounds, and especially we talked about electrolysis of aluminum oxide. This part is clear, right? There's no confusion in what we covered in the last class.
No,
Okay,
no.
good. Okay, now let me go ahead and let's start discussing what will happen when we talk about electrolysis of a solution. Because remember, when we had talked about electrolysis, I told you that the ionic compound has to be either in a molten state. So molten is when it just melted it.
Molten
That's
solution
it.
or
Oh,
aqua solution?
yes, it has to be in an aqueous solution. Now, in an aqueous solution, things get a bit complicated. How do things get complicated? In a molten solution, so if I have molten sodium chloride, then I have only two ions. I have sodium ion and I have chlorine ion. That's it. I only have two ions. So it's very easy for me to decide which ion will go to the cathode and which anion will go to the anode because there are only two, right? It's so easy to decide. But
Yes.
what happens when we have a solution? Because when I make a solution, I'm adding water to it. So now instead of two ions, I have four ions. I have
Yeah.
hydrogen and hydroxide. And along with that, I will, for example, if I have a solution of sodium chloride, so I will have sodium ion and chlorine ion. So whenever anything becomes in a solution, you are going to be stuck with four ions. And now you have to decide which ion will go to the cathode and which will go to the anode. Now, the way we normally decide it is this. I think I showed you this last time.
Yes.
We have the reactivity of metals. So if you remember, I told you that when we talk about atom, not ion, this is all ion. If I talk about atoms, so the reactivity of metal decreases, right? The reactivity of metal decreases down, downwards. So for example, potassium atom, sodium atom. So between potassium and
Yes.
sodium is more reactive. Between sodium
Yes.
and calcium is more reactive. This is for atoms, but this is not atoms. This is all ions.
So do we
Ions,
have to memorize the table?
if you memorize the table, it will make it easier for you because we have a entire chapter on just metals as well. So it will be easier for you to solve questions related to it.
Okay.
So, for the ions, it is opposite. So, for the metal, the reactivity decreases, right? But for the
Yes.
ion, it's the opposite. Reactivity increases. So, potassium metal is less reactive. Sorry,
Yes.
potassium metal is very reactive. Potassium metal is very reactive, but potassium
Yes.
ion is less reactive. Okay, so
And then
let's go.
silver is less reactive.
Yes, silver metal is very less reactive, but silver ion is very reactive. So the ion is opposite of the metal. Okay, so silver
Oh.
metal, yes. So that's what I'm saying. The ion is opposite. So potassium metal is very reactive, but potassium ion is not is less reactive.
Oh,
Silver,
that's right. So
yes,
there is a
silver
difference.
it is different, exactly. So if they ask you about the metal, if they ask you about the atom, so then as we go down, it becomes less reactive. But if they say ion, sodium ion, calcium ion, then it becomes more reactive. So it's the opposite of each other. Okay? So when you study metal, that's why you have to read the question carefully. If the question is about ions, then the ions become more reactive. But if it's about the metal becomes less reactive. So for example, zinc ion let's take zinc and lead. Okay. So zinc metal is more reactive. Lead
Yes.
metal is less reactive.
So we
But
can
when I
say the zinc ion is more reactive than the lead ion, right?
no, one second. Zinc, okay, one second. For the metal, as we go down, reactivity increases. But for ions, as we go down, reactivity, I'm sorry, I wrote it the other way. This is decreases over here. Remember this. If it's
Okay.
a metal, it will decrease. It will become less reactive. If it is an ion, it will become more reactive. Okay?
Okay.
Metal will become less reactive. Ion will become more reactive. So if I say between zinc and lead, zinc metal and lead metal. So what happens? Metal gets less reactive, meaning that lead will be less reactive. But the ion is opposite. The ion becomes more reactive.
Increase.
Yes. So the lead ion will be more reactive. Lead metal is less reactive, but lead ion is more reactive. So over here, let's take now this, you and I are now performing in electrolysis. Okay. This is a setup that we generally use when we are doing electrolysis of a solution, right? This
Yeah.
is quite similar. The setup is similar to what we've studied before. The things are exactly the same. This over here is the cathode. This is the cathode over here, and this is the
Yes.
anode.
Yes.
And these tubes are all filled with the solution, the electrolyte. Okay. So
Yeah.
what we have over here is that I have given you sulfuric acid. Now, I have provided you with sulfuric acid, and I'm saying, Dania, you're doing electrolysis of sulfuric acid. It's a solution. Now, what are you going to get at the cathode? What are you going to get at the anode? So, what are you going to do? First thing you're going to figure out, what are the ions present? How many ions are present in the solution, right? So,
Yes.
we first of all, it's aqueous, meaning that it has water in it. So, what
Yes.
ions do we have in water? Hydrogen,
Uh, Hydrogen and
yeah, hydroxide. This one OH minus is known as hydroxide.
yeah.
Hydroxide. We call this hydroxide, right?
Yes. Yeah.
Okay. So those are coming from the water. What about from sulfuric acid? What do you think?
Sulfur.
Okay, this is going to be one complete ion. Okay.
Also,
Yeah.
sulfuric. Yeah.
Yes. You'll get us. This is known as sulfate. This is known as sulfate. I'll do this in more detail with you, the basic topics of it. This is known
Okay.
as a sulfate ion, and it has a charge of 2 minus, right?
Yes.
So now you have 4 ions. Now you have to decide who is going to go to the cathode and who is going to go to the anode. Now, it's you can instantly look at this and tell me which ion will go to the cathode. Can you identify which ion will go to the cathode?
Um. Hydroxide.
One second. Tell me one thing. Who goes to the cathode? The positive ion or the negative ion?
The negative.
Okay, one second. Remember this. The cathode is the
Positive.
negative.
Oh. Oh. Yeah.
No,
Negative. Yeah.
cathode is the
Negative.
negative electrode. Okay.
Yeah.
So it will get the opposite ion. It will get the positive ion, right? So cathode
Yeah.
will attract the cation. The cation is positive.
So it's gonna be the hydrogen, right?
Exactly. It's going to be the hydrogen. Hydrogen is going to go to the cathode. Now, hydrogen is going to go to the cathode. When hydrogen will go to the cathode, what will happen? What will happen is this, that the cathode is negative, meaning that it has a lot of electrons. So when the
Yes.
hydrogen will go to the cathode, it is an ion. It's positive right now. It's an ion. It does not have that many electrons. So when hydrogen will go to the cathode, it will gain
Uh,
electrons, right?
yes, gain.
It will gain electrons and it will turn into hydrogen atom. So now to complete my equation, all I have to do is that I have to balance it. Do you know the formula for hydrogen gas?
Hydrogen gas.
Hydrogen gas, yeah, what's the formula for it?
Yeah, I don't remember their formula.
Oh no, I think you're getting confused because you told me in the last class. Remember, I was giving you examples of gases that are diatomic. Like I told you, bromine is Br2, oxygen is O2, so hydrogen is,
Hydrogen is H.
yeah, H2, right?
Yeah, H2.
Yeah. So you're going to write down H2 because hydrogen, the formula for hydrogen gas is H2. Then now I have to balance it. Okay. So I have two hydrogen atoms. So how many ions do I need? Two. So I will
2.
write down 2. And then I told you we will multiply. The charge on hydrogen is +1. So 2 multiplied by 1 becomes 2. So how many electrons do I need? 2.
2.
And what is this process that is taking place at the cathode? Do you remember what it's
Ba-
called?
balance equation.
Yeah, this is the equation, the process. What is it called? The process is called reduction.
Oh yeah,
Yeah, remember
reduction.
reduction was the gain of electrons. Okay,
Yes.
so what's going to happen that the hydrogen ion is going to go to the cathode. Over there, hydrogen ion will undergo reduction. It will gain electrons and it will turn into hydrogen gas. And what will you see? What will you observe? You will see that hydrogen gas has been collected. You will see that hydrogen gas has been collected over here on top of the cathode. Okay, so on top of the cathode, you will see that hydrogen gas has been collected. Now, this was easy and simple. Now, let's talk about the anode, the negative electrode. Now, the negative electrode makes things a bit complicated. How does it make things complicated? The reason it makes things complicated is because who goes to the anode? So the anode is the positive electrode. So who goes to the anode? The anion. That's the negative ion.
Yes.
Now, in negative ion, I have both hydroxide and the sulfate ion. Now, which
Yes.
of these is going to go? Who is going to go? That's what you're going to have to find out. So we will go to the table and we are going to look at which one is high and which one is low. The one that is lower is more
It's
reactive.
hydroxide.
Yes. Sulfate is high, hydroxide is low, meaning that
Sulfate is the we take the
hydroxide
sulfate.
is more reactive. So,
Oh,
yes, so we will take hydroxide. Whichever one is more reactive, so think of it this way, that whichever ion is more reactive, it's easy for it to go to the anode. The other one is not very reactive, so it's not easy for it to react. Hydroxide, so between hydroxide and sulfate, hydroxide is the more reactive one. Okay, it's the
yeah.
more reactive one. So what happens that the hydroxide ion goes to the anode. So when the hydroxide ion goes to the anode, what happens? Now, anode was, if you remember, we had studied that anode was loss of electrons, right? At cathode, because cathode has got a lot of electrons, it's negative, it has a lot of electrons. So
Yes.
reduction was happening.
It's gonna
right?
lose electrons,
Yes,
right?
it's going to lose electrons. It's going to lose electrons. And when it loses electrons, it gives you two products. You can learn this.
Yes.
It gives you two products. Okay. It will
Yeah.
give you water
Yeah.
and it will give you oxygen.
Yes.
Now, if you remember, I had told you we don't write down the electron with a negative sign. Remember?
Yes.
I had told you we will move it to the other side. So that's
Yeah.
what we are going to do. I
So
will
we
take
just
my,
keep the
yes,
alone.
yes, we keep the OH alone. Exactly. So I will keep the OH where it is and I will put the electrons over here, plus electrons. And now I just have to balance it. So I will balance the equation like normal. Okay. So I'm just going
Okay.
to balance the equation the way you balance a chemical equation. Okay. So
Okay.
I'll put a 2 over here and I'll put a 4 over. I'll teach you balancing. By the way, I'll go over balancing with you. We will do a whole practice worksheet and everything, and I'll teach you how we balance equations. So
Okay.
the purpose of balancing is that the left side and the right side should have the same number of atoms. So for example, how many hydrogen do we have? 2 hydrogen and 2 hydrogen, right?
Yes.
So 2 multiplied by 2 gives us
4.
4. So we need to have 4 hydrogen. So we get 4 hydrogen. Similarly, how many oxygen do we have? We have 1 oxygen over here. 2
Yes.
multiplied by 1 is 2. And then we have 2 over here. 2 plus 2 is 4. So we
4.
also have 4 oxygen. So we need to make sure that we have 4 hydrogen and 4 oxygen on sides. Right? Now,
Yes.
final thing we have to balance is electrons. How many electrons do we need? We have 4 ions. The charge is -1. 4 multiplied by 1 gives us 4. So how many electrons do I need?
4.
And that's it. By the way, Danya, if you just want to make things easy for you, you can always just learn the equation for this hydroxide.
Yeah.
And then
Yeah.
any question you get for hydroxide, you can just write down the same equation again and again and again. You don't have to
Yes.
solve it every time.
So this equation is oxidation, right?
This exactly, this is oxidation. We are,
Which is the lose of electrons.
yes, correct. Very good. That is the loss of electrons. So what is the end product? The end product is that at the cathode, I am getting hydrogen gas. At the
Yes.
anode, I am getting oxygen gas,
Yes.
right? And
Yes.
that is the final product. I have got oxygen gas and I've got hydrogen gas. So this is how we do electrolysis of your
Solution.
solutions, especially dilute solution.
Yes, dilute solution.
Okay. Now, this was one scenario. Now, the rules that I just told you, they are applied in most situations. Most electrolysis, you can use the rules I just taught you, right? But
Yes.
there is few electrolysis in which the rules are slightly different. And one of them is this electrolysis of, notice the,
Concentration.
yes, concentrated sodium chloride. Electrolysis of concentrated sodium chloride is different. If we were doing dilute sodium chloride, we would solve it exactly the same way, like this.
The same as we did with the
But
sulfuric.
concentrated sodium chloride, yeah, concentrated sodium chloride becomes a bit tricky. Dilute sodium chloride, you would do it the same way, like sulfuric acid, same way. With
Yes.
concentrated sulfuric acid, it gets slightly tricky. I will tell you how. First of all, let's see. What is this? It's a sodium chloride
Chloride.
solution, right? Yeah.
Yes.
And it's a solution. So in a solution, what did I tell you? We have 4 ions.
Yes.
We have hydrogen, we have hydroxide,
We have
We have,
sodium
yes, correct.
and
And
chloride.
good job, correct. Now, again, you have to decide who is going to go to the cathode and who is going to go to the anode. Now, for the cathode, I have two options. What are the two options that I have?
I have hydrogen and sodium.
Sodium, exactly, correct. Now, which one of them is going to the cathode? We go back and look at the table. So between hydrogen and sodium, who do you think is more reactive?
Um, Hydrogen.
Correct, completely correct, because hydrogen is low, sodium is high,
Yes.
right?
Yes.
So between sodium and hydrogen, who will go to the cathode?
Hydrogen.
Good job. So hydrogen ion will go to the cathode. And after that, what will happen if I say what will happen? What process happens at the cathode?
Reduction.
Correct. And what is reduction?
Gain of electrons.
Exactly. So what will happen? Hydrogen will gain
Will
electrons.
gain
Right?
electrons.
Yes. And I will get hydrogen gas. What's the formula for hydrogen gas?
H2.
Correct. So now I will balance it. For two hydrogen atoms, I need two hydrogen ions and two electrons. So this is solved. Now, what is going to happen at the anode? This is where it gets a little bit tricky. What two ions are my options for the anode? Which two ions can go to the anode?
Hydroxide and chloride.
Correct. Between hydroxide and chloride, which one is more reactive?
Chloride.
Okay. Do we look at the lower one or the higher one? Between sodium and hydrogen, what did you told me that
The lower one.
yeah, so between chloride and hydroxide, who should be more reactive?
Hydroxide.
Hydroxide. You are correct. Hydroxide is more reactive. But the ion that will go to the anode will not be hydroxide, it will be
Chloride.
chloride. There is a reason for it. The reason for it is the concentrated.
Yes.
This is a concentrated solution. So it has a lot of chloride ions, right? It has a lot of
Yes.
chloride ions. Now, you can ask me the same question. You can say, ma'am, it's a concentrated solution. So the sodium ions should also have been a lot. Sodium ions should also have been a lot. So how come we did not look at the concentration of sodium ions? You said hydrogen will go. Why over there? Why did you say that it's highly concentrated? So sodium should go. There is a reason for that. The difference between sodium and hydrogen, reactivity difference between sodium and hydrogen is a lot. But the difference in
So
reactivity.
it's based on the reactivity.
Yes. Difference between hydroxide and chloride, the reactivity difference is not that much. They're close to each other, aren't they?
Yes.
So
Yes.
in hydrogen and sodium, the difference in reactivity is so much that even though we have a lot of sodium ions, it's really concentrated, the reactivity wins. Hydrogen is like, it does not matter how many sodium ions are present. I am so reactive, I can go to the cathode. But between hydroxide and chloride, the difference in reactivity is less. So we have a lot of chloride ions. And what will happen? The reactivity loses. The concentration wins. So you remember this, even sodium will have a lot of concentration. Even the concentration of sodium ions will also be high. But the concentration of sodium ion is not high enough to overcome the difference in reactivity. The difference in reactivity is just too much. It doesn't matter how many sodium ions are there, it's just too much difference. But between chlorine and hydroxide, it's a small difference. So the number of chlorine atoms, the concentration of chlorine atom wins because the reactivity is not that much different. So the concentration of chloride ion wins. So who goes to the anode? Chloride ions. And
Chloride.
what happens at the anode? What process happens?
Oxidation. Oxidation.
Correct. And what is oxidation?
Lose of
Exactly.
electrons.
So my chloride ions will go to the anode. Chloride will lose 2 electrons and give me a atom. Now
So
I
now we
need to,
have to balance.
yes. What's the formula for chlorine gas?
Chlorine gas Cl2.
Yes, correct. So how many ions do I need?
2.
Correct. And how many electrons do I need?
2.
Okay. I need to make one more change. Can you tell me what other change I need to make?
Uh, we bring two the 2 electron to the other
Mhm.
side.
Excellent. Very good. So I'll take these 2 electrons, I'll put them on the other side, and I will write down plus 2 electrons. And that's it.
Yes.
Okay.
Yes.
Now that's so at the cathode, what is going to be produced? Hydrogen gas. At the anode, what will be produced? Chlorine gas.
Chlorine
Now,
gas.
yeah. What ions are left behind? Hydrogen ions are gone. Chloride ions are gone. What ions
We
are left?
have hydroxide and sodium.
Good job. So at the end of the process, what will be left behind? Sodium hydroxide. That's an alkali, right? Sodium hydroxide is an alkali. Sodium
Yes.
hydroxide will be left behind in the
What's the meaning of alkali?
alkali. Okay, you know how we have acidic substance and substance
Yes.
which is an acid. So alkali
Yes.
is the opposite of it. So alkali is the one that neutralizes.
Alkaline. It's like
Yes,
alkaline.
exactly. Yes, alkaline is the opposite of acid. Okay,
That's
we have a whole chapter on acids and alkali. So we will do that chapter as well. So at the end of this process, I have 3 products. I have hydrogen
hydrogen.
gas, I have
I have
chlorine
chlorine.
gas, and I have sodium hydroxide. So we have 3 things. And when we talk about the process, this process is done at an industrial level. Like they do this process in industries. And the
Yes.
reason they do it is because they get these 3 products. These 3 products are really, really, really important, right? Take a look.
Because it's like for medical and
Yes, for
yeah.
different things, exactly. Hydrogen, for example, it's used as rocket fuel.
Yes.
You use hydrogen to make ammonia. You use
Yes.
hydrogen to make hydrochloric acid, for
Hydrochloric
example.
acid.
Yes.
Yes.
Chlorine is used to again make hydrochloric acid. We
Yes.
add chlorine in water, right? In water,
Yes.
we add swimming pools and all, we add chlorine to it. Chlorine goes
Yes.
in plastics. Chlorine goes
Yes.
in disinfectants. So all of these have got different uses. So all 3 products, hydrogen, chlorine, and sodium hydroxide. So sodium hydroxide, for example,
There's some questions that would ask like what's the
yes,
use of hydrogen chloride and sodium hydroxide?
yes, they do. That's exactly why I put the table over here, because they ask you what are the uses of this hydrogen, chlorine, or sodium hydroxide. So sodium hydroxide, for example, we use it to make soap, or we use it to extract aluminium, or we use it to make clothes. So this is why it's a huge industry process, because they make hydrogen, chlorine, and sodium hydroxide, and then they sell it further to other people so they can make different products. So this is electrolysis of sodium, concentrated sodium chloride. All clear, right? No confusion so far?
No confusion.
Okay. Um, 1 second. Similarly, let's take another situation. We are doing electrolysis of concentrated hydrochloric acid,
Hydroxide acid.
right? So
Yes.
now, can you tell me what ions will be found in concentrated hydrochloric acid? It's a solution. Of course, acid is a
Okay,
solution.
so it's hydrogen,
Correct.
and then chloride.
Correct. And from water?
Uh, for water, again hydrogen,
Yes.
and hydroxide.
Correct. Okay, so who will go to the cathode?
The cathode will either hydrogen.
Hydrogen. You only have one option. Both the
Yes.
positive ions are hydrogen. Correct. Okay. Can you make the equation for me? What the equation will be at cathode?
It's gonna be 2H
Mm-hmm.
plus
Mm-hmm.
2E minus,
Mm-hmm.
which makes hydrogen 2.
Yeah, good job. Correct. And between anode, we have
Do
again
we
two
have to
options.
make a small change?
In the
Which
cathode one, we have to make a small change.
uh aren't we supposed to? Oh yeah, we don't need to change it. Yeah.
Yeah, because in cathode, it's gaining electrons. So the electrons
Yes.
are already with a plus sign. So not that the change is in anode. So in
Yes.
anode, we have chloride and hydroxide. First, tell
Yes.
me which one of them is more reactive. Is chloride more reactive or hydroxide more reactive?
Hydroxide.
Yes. But this is concentrated. So if it's concentrated, then who should go to the anode?
Uh, Chlorine.
Correct. What will my equation be?
2Cl.
Mm-hmm.
With an arrow.
Mm-hmm.
Cl2.
Correct.
Plus.
Mm-hmm.
Uh, two. Two mi. 2 minus. 2E
Two.
minus.
Yes. Correct. Good job. Good job. Right? So you are going to get hydrogen gas on the cathode and chlorine gas on the anode. Now, keep this in mind. If this was dilute acid, then hydroxide would be the one that would go to the anode. Okay? But
Yes. Yeah.
because it's concentrated, that's why chloride is going. Now,
Yes.
let's take another situation. I am doing electrolysis of copper sulfate. Okay? I am doing
Yes.
electrolysis of copper sulfate solution. So if it's copper sulfate solution, I'll write down the ions. We are doing copper sulfate solution.
Yes.
So what ions can you identify?
Okay. So for water,
Mm-hmm.
hydrogen and
Correct.
hydroxide.
Correct. And
And for copper sulfate is copper
mm-hmm.
plus 2
Mm-hmm.
with sulfuric and minus 2.
Correct. Good job. Now you have to decide who will go to the cathode. So what options do I have for the cathode?
For the cathode, we have hydrogen and copper.
Right. So you have to choose between hydrogen and copper. So between hydrogen and copper, who do you think should go to the cathode?
So at the cathode, we have to pick the most reacted, right?
Yes,
Or then,
exactly.
oh, okay. So should we choose copper for this
Yes,
or?
exactly. Copper is correct because copper is lower. Copper is correct. Good job. So we are going to choose copper. Can you make the equation for me? What the equation will be at the cathode?
Okay, so Cu,
Mm-hmm.
an arrow,
Okay. Are you sure you want
and
to put an arrow? Okay, one second.
uh,
What happens at the cathode? What happens? A process happens at the cathode?
a reduction, which is gain of
Yes.
electrons.
So should I add
So
electrons or should I subtract electrons?
add electrons.
Yes, good. So how many electrons should I add?
2.
Good job, correct. And what will I get at the very end?
Cu.
Good job, Correct. So copper metal will form at the cathode. And look over here. You can see the copper color method. It is forming at the electrode. Well done.
Yes.
Now,
Yes.
let's talk about the anode. What options do I have at the anode?
We have hydroxide and sulfuric acid.
Right. So between hydroxide and sulfate, who should go to the anode?
Hydroxide.
Hydroxide. So hydroxide is going to go to the anode. Do you remember what equation I had told you for hydroxide?
So it's hydroxide with an arrow,
Mm-hmm.
and it's H2O
Correct.
plus O2
Correct.
plus 2E minus.
Okay. You need to just balance it out. You need to balance it out. The
Yeah,
reason you need
so
to, yeah,
in the H we put beside it a 2.
yeah, correct. H2O
And
is 2.
for and then for hydroxide we
Yeah,
add a 4.
correct. And how many electrons then?
Electrons is 2.
1 second. For electrons, we multiply. Remember, I told you that we
Yeah.
multiply the number
So
by the charge.
4.
Yes, 4 electrons. Correct. This will be the final equation. So what am I going to get at the anode? At the anode, I'm going to end up getting oxygen gas. So hydroxide will go to the anode. The copper will go to the cathode. What will I be left with? What's going to be left at the end?
Hydrogen and sulfuric acid.
Can you tell me what that will make? Can you guess what that will make? Hydrogen and sulfate ion?
Uh, Hydrogen, no. Mm,
It will make sulfuric acid, right? Hydrogen and
yes.
sulfate
Yeah.
gives you H2 sulfuric acid. So that
Yeah.
is good. Okay. Now, when we talk about electrolysis, so one of the uses for electrolysis is extraction of metals, right? I told you that we
Yes.
can use it to extract metals. That is what we studied in aluminium. Now, another use for electrolysis is purification. So if I, for example, if I have a piece of metal that is impure, right? I can use electrolysis to purify
Make
it.
it pure.
Yes, exactly. How am I going to do that? So I come up to you and I say, Dania, I have this sample of copper. It's impure. It's got like stuff mixed up inside of it. Can you help me with the purification? So you'll say, yeah, ma'am, sure, that's no problem. First thing is first, the impure copper or the impure metal, whatever impurity is, right? You will attach it to the positive electrode. The positive electrode is anode.
Yes.
So who will go to the anode? The impure one. Remember that. The
Yes.
impure one will go to the anode. And what will I put on the cathode? I will
Pure.
put, yes, the pure metal. The pure metal will go to the cathode. Now, notice if you remember, in electrolysis, I had told you we use inert material to make electrodes, right? I told you we use graphite or we use platinum. Remember, that's what I told you, that for electrolysis we use inert material, but over
Yes.
here we're not using inert material, we're using metal. So copper, impure copper is on the positive side and pure copper is on the negative side.
Negative side.
And what about solution? What solution will I put? The solution I will put also has to be it also has to have what in it? It also has to have copper in it. I need to use a solution with copper in it. Okay. So in this case, they used copper sulfate solution. So if you were doing purification of zinc, you would use a zinc solution like zinc sulfate. If you were doing purification of silver, you would use a silver solution. So we have to match it. Whatever purification we are doing, the solution has to be the same. Okay?
Yes.
Now, what is going to happen in the process over here? What's going to happen is this. We have impure copper, right? So
Yes.
inside the impure copper, what's going to happen? that the copper metal, this is the copper metal, right? This
Yes.
copper metal is going to lose electrons and it is going to turn into copper ion. Okay. So what is happening that the copper metal is going to lose electrons because what happens at the anode? Oxidation. And oxidation is loss of electrons. So copper will lose electrons to become ion. It will get a charge of 2 plus, right? Copper has a charge of 2 plus.
Yes.
So how many electrons should I add?
Electrons?
Yeah. And look, I'm writing this equation, right? What
Yes.
happens at the anode? What happens at the anode? It loses electrons.
Yes.
So copper will lose electron and it will become positive. So
Yes.
copper has a charge of 2 plus. They have written copper 2. So it has a
Yes.
charge of 2 plus. So how many electrons should I add to balance the equation?
2.
2. And can you tell me one more correction I have to make to the equation?
Do we move something?
Yes, exactly. What do we move?
The 2E minus?
Yes, correct. So I'll move the 2E minus and this will be my equation. Right? So what is
Yes.
happening? What is being formed at the anode? What is being made at the anode? Copper ions. So copper ions will be made at the anode. Now,
Yes.
these copper ions will enter the solution. And when they will enter the solution, they are positive ions. Positive ions are attracted to the cathode, right? Positive ions go to the cathode. So the copper ion, this copper ion, where will it go? It will go to the, this copper ion will go where?
To the anode.
1 second. The
To
copper
the
ion,
cathode.
yes, because so the anode is basically dissolving. The anode is dissolving, okay? The anode is going to dissolve, it's going to break down. So the copper metal in the anode, impure copper, right? It's basically impure copper because it has got other metals mixed inside of it, right? It's got other metals mixed inside of it. So what will happen that the impure copper will turn into copper 2 plus. It will turn into copper ion. It will lose electrons and turn into a copper ion. It will turn into a positive ion. Now we have positive ions. Where do the positive ions go? Positive ions always go to the cathode. So this copper ion will go to the cathode. And what process happens at the cathode?
The cathode is reduction.
Yes. So what will happen? It will gain electrons. And when it will gain electrons, it will turn into copper metal.
Yes.
So what's going to happen that the anode is going to keep on dissolving. It's going to keep on breaking down and producing copper ions. These copper ions being formed from the anode will go to the cathode. And on the cathode, the copper ions will keep on depositing. They will keep on attaching. So slowly, the impure copper, the anode will slowly dissolve and dissolve and it will break down. Right? All of the impurities, all of the other metals mix inside the impure copper, they will just fall to the bottom because they are not going to the cathode. The copper is going to the cathode. All the other impurities, they will just fall to the bottom of the tank. The copper ions will go to the cathode. And when the copper ions will go to the cathode, they will turn into copper metal. And when they will turn to the copper metal, they will deposit on the cathode. They will attach to the cathode. So you will be able to see the anode is slowly dissolving away and the cathode is, gaining mass. Cathode is getting bigger and bigger and bigger. Cathode is gaining mass. The anode is dissolving and dissolving and dissolving. So the copper is going to be, so what's going to happen at the anode? What am I making? At the anode, I am making copper ions.
Ion.
Where are those copper ions going? Those copper ions are going to the
The
cathode.
cathode.
What is happening at the cathode? The
It's
ions
gonna
are
turn to metal.
Good job. Excellent. And what is the result going to be? Eventually, all my impure copper is going to dissolve. The
And turn
impurities, yes,
to a pure metal.
pure, yes, exactly. So my cathode will get bigger. The mass of the
Yes.
cathode will increase, the mass of the anode will decrease, and all the impurities will be at the bottom of the tank. And I have
Yes.
done purification.
Yes.
So this is one application of this entire process, right?
Yes.
Now, another thing that we use, another application. So one of the,
Electrobraiding.
yes, electroplating. So when I have a piece of jewelry, I have a piece of cutlery, I have a piece of, my pots and pans, anything that needs to be covered with a layer of metal, I will do electroplating. So in electroplating, one thing that I have to remember, who will be the cathode and who will be the anode. So remember this.
Yes.
The
So
anode,
the anode is gonna be the
metal.
electrolyte or the thing, metal, and
What?
the cathode is gonna be an ion.
So yeah, so an anode is going to be the metal. For example, if I have a piece of spoon, they have shown a spoon. We'll take a spoon. I have a piece of spoon and I want to cover it in silver. So the metal, the silver, because I want it to be silver plated, silver will be the anode. Similarly, if I want to cover it in gold, I want it to be gold plated. So the gold is going to be the anode. The positive terminal is always going to be the positive terminal is going to be the metal. What is
Metal.
going to be the cathode? My object. Whatever
Oh.
object, yeah, whatever object I want to cover. So if I want to cover a spoon, spoon will be the negative electrode. If I want to cover a piece of jewelry, my jewelry is going to be the negative electrode. So my cathode will be whatever object I want to cover. And the anode is going to be the metal, whatever metal I want to cover it with. Now, what's going to happen in this case? Let's say you have a piece of spoon and you want to cover it in silver. You want to do silver plating. How were you going to do it? You took silver and you attached it to the positive side of the battery. So it will become the anode, right? The positive one is anode. Then you will take your spoon and you will attach it to the negative side of the battery. So that is the cathode. So who is the cathode? Our spoon. And who is the anode? Piece of
Is the metal.
yes. And then I'm going to take an electrolyte, a solution. What will my solution be? So remember how I told you in purification, we have to make
Yes.
sure that the solution matches the metal. So we were
Yes.
doing purification of copper. So we used
Yes.
copper solution.
Yes.
So over here, we're using silver. We
We're
will
gonna
use,
use silver solution, right?
yes, we're going to use a silver solution. So we can use something like silver sulfate, right?
Yes.
Then after that, what are we going to go ahead and do? So the process will happen like this. The process will start at anode. What happens at the anode? Reduction or oxidation?
Reduction.
At the anode.
Yeah, oxidation.
Yes, oxidation, because anode is the positive one. Oxidation.
Yes.
So what's going to happen? That the silver metal is going to,
It's gonna lose.
correct, it's going to lose electrons. And what will it become?
It's gonna be metal.
Is it going to be a metal or is it going to be an ion? It's losing electrons. If it's losing electron, it's
Yeah,
become,
it's an ion. Ion.
yes, if it's losing electrons, it is becoming positive, right? So it's going to turn
Yes.
into a silver ion. Now,
Yeah.
okay, now this silver ion, what is going to, so the process, this process is similar to this one, purification.
Yes.
So over here at the anode, we were making copper ion. So similarly, Over here, we are making silver ion. Now, where
Yes.
is the silver ion going to go? Silver ion is done. Where will it go?
It's gonna go to the cathode. It's gonna go to the cathode.
Yes, it's going to go to the cathode. So silver ion is going to go to the cathode. And what happens at the cathode? What process happens?
Reduction.
Reduction. What is reduction?
Gain of electrons. So the silver is gonna gain and become
Yes,
a silver metal.
good job. So the silver metal is going to start to deposit. It's going to start to add on top of the spoon. And slowly, slowly, that entire silver is going to cover the spoon, and the spoon is going to be covered in silver metal. So this is electroplating,
Plating.
right? So
Yes.
electrolysis, we use it for a few things. We use
Extracting
electrolysis.
metal.
Yes, we use it for extracting metals. We use electrolysis for electroplating and
Yes.
for purification. Now, one thing you will notice is that in your syllabus, it does not say electrolysis. It says electrochemistry, right?
Yes.
That's what it
Yes.
says, electrochemistry. That's because, so in electrolysis is
Is
an,
electricity.
yeah, electrolysis is an, do you know what do we mean by endothermic?
Oh yeah, endothermic.
Endothermic is when we
Is
give energy, when we have to
yes.
add energy, when we have to
Yes.
put in energy, that is
And then
endothermic.
exo is gonna surround at the
Yeah,
surrounding.
exo is release of energy. So when the release is energy is being released, that is exothermic.
Yes.
Electrolysis is an endothermic process. Why is it an endothermic process? Because I have to provide electrical energy. Because I have to give electrical energy so that the compound will break down, right? What
Yes.
was electrolysis? Breakdown of an ionic compound using electrical energy or using electricity. If I don't give
Yes.
electricity, if I don't attach a battery to my system, electrolysis will not happen.
It won't work.
Exactly. But our topic is electrochemistry, meaning that we can also use the same principle to make electricity. So we can use a cathode, we can use an anode, we can use a solution, and we can do the opposite. We can use it to make battery. We can do an exothermic process. And that is the process that is used in your batteries, in your cells. The batteries, the cells, they use the same concept. That's why the topic is called electrochemistry, not electrolysis, because we are
Yes.
using electricity for chemistry. So we are going to be using the same electricity, but we are also going to be making that electricity. So I will use the same cathode, I will use the same anode, I will use the same solution. The electrolyte is the solution. I use the same
Yes.
solution and I will be making electricity. So
Yes.
hold on one second. So for that, we are going to now study the next portion of this topic, the final portion of the topic, and that is basically your one second. So we have to study about what will happen inside a battery or what will happen inside a cell. And along with battery and a cell, we are going to study
Fuel
about,
cell.
yes, fuel cell. So we have a normal chemical cell, right? A normal chemical cell that works, a normal one. And then we have a more special kind of cell that is known as fuel cell. Okay, Tanya, I think we'll go ahead and stop it over here for today. And then, inshallah, in the next class, we will
Yes.
do the topic of battery and cell. And then we will start to practice past paper questions on the topic, inshallah. Okay?
Okay. Thank you.
Okay, thank you so much, Dania. I'll see you in the next class. Have a good day.
Bye. Thank you. Bye.
Bye. Allah Hafiz.